Hi there, hope you're having a good day. It's the end of chapter 6.2 and I just want to go over some of the homework from last night. I left you with one question to do last night, and that was this question here on the screen. I asked you to basically look at what happens in this chemical reaction. When two H2s react with an O2 to make water, I get two molecules of H2 gas reacting with one molecule of oxygen gas to make two molecules of H2O gas. Now that was the question that, or H2O liquid, that's the question that was question 7 in the textbook on page 212. Now, all you had to do in this question was basically copy down the chart that they had in the textbook. So that's what I've done here, and I have gone ahead and I've said, okay, so if we know that two molecules of H2 react with one O2, again, notice two H2s reacting with one O2 to make two waters. Right? That tells me about the number of molecules that are reactants and products. It also can be used to tell me about moles. So I can now say that 2 moles of H2 gas can react with 1 mole of oxygen gas to make 2 moles of water. Right? So that's allowing us to look at the moles in terms of products and reactants, and then we have to extend that one more step to say I'm not as much concerned about moles as I am about grams. So we did the calculation where I calculated if I have 2 moles, I can calculate the mass, because I know that mass is equal to the number of moles times the molar mass. The number of moles is 2 moles, and the molar mass is going to be the molar mass of H2 up here. The molar mass for H2 is 2 H's, which is 2.02. So here's my molar mass for hydrogen gas, and I end up with 2 times 2 moles at 2.02 grams per mole gives me 4.04 grams. If I do the same thing with oxygen, I can determine the number of grams of oxygen if I have 1 mole of oxygen reacting, and the molar mass for oxygen, which is O2, is going to be 2, which is 32.00 grams per mole. 1 mole times 32 grams per mole will give me 32 grams. So I can calculate how many grams of oxygen are going to be used. So I now know the number of grams of hydrogen gas and the number of grams of oxygen gas that are going to be used. Then lastly, I want to calculate the number of grams of water that are going to be made. So if I get 2 moles of water being made, and I can calculate the molar mass for water like we did on our test, 2 H's plus 1 O is 18.02 grams per mole, and then that tells me that I will get 36.04 grams of water. Okay, and really the purpose of this exercise was to confirm, yet again, our law of conservation of mass, that if I have all of this reactant here, 4 plus 32, which is 36.4 grams of reactants, then I will get 36.04 grams of products. And I know that my reactants masses are equal to the masses of the products. Okay, so there's question 7 from the homework last night. Now I hope you're thinking as you're working through the homework with me that if you get through watching the video, you can always pause the video or go back in the video to wherever we left off, or whatever you want to go back and revisit. Now, I want to look at a new topic today, which is something called mole ratios. Mole ratios basically allow us to predict, if I know how many moles of reactants I'm starting with, I can determine how many moles of products there will be. Or if I know how many moles of product I want, I can determine how many moles of reactants I need. Now, there's a sample here. Okay, so we're in 6.3. Right? And again, we're using mole ratios to predict the amounts needed or used in a chemical reaction. Okay, so most important, okay, absolutely most important here. put some stars beside this, right? Start with your balanced equation. If your equation's wrong, this is probably a 5-mark question. If your equation's not balanced, the entire question is wrong. Right? So you have to always, always, always start with a balanced chemical equation. We know how to balance chemical equations. So question A here says, how many moles of each reactant are needed to make 2 moles of KBr? Right? How many moles of K? How many moles of Br2 if I want to make 2 moles of KBr? So I'm going to make this really big here. So if I want to make 2 moles of K, I need to start with a balanced chemical equation. I just finished saying that. I'm going to make this really small. I'm going to start with, so let's get rid of this here. I'm going to balance my equation. To balance it, I need a 2 in front of the potassium and 2 in front of the KBr. So I now have 2 Ks on the left, 2 potassiums on the right, 2 bromines on the left, 2 bromines on the right, and it's balanced, it's ready to go. Now the question, it says, if I want to make 2 moles of KBr, how many moles? Number of moles of Br2 is unknown, and the number of moles of K is unknown. Now, in order to solve for this, right, we're going to use mole ratios. Now, the ratios are the ratios of the numbers that are the coefficients in our chemical equation. 2, 1, and 2. Right? Those are the ones that are going to be our mole ratios. So I'm going to switch back to my whiteboard so I've got some room to work here. Okay, so we had 2 potassiums reacting with a Br2 to make 2 KBrs, and I know my number of moles is 2 moles. Now, if I want to calculate my number of moles of Br2, okay, I'm going to look at the question. I'm going to say the number of moles of Br2 is my unknown. Right? It's my unknown. And it's going to be equal to the number of moles that I know, which is the number of moles of KBr. Sorry, let me just go back. It's going to be my number of moles of KBr times the mole ratio. So what is the mole ratio? The mole ratio says I'm trying to solve for Br2, and I know the number of moles. My unknown is Br2 and my known is KBr. So I'm going to look back at my balanced equation. I'm going to say, what was the number in front of KBr up in the equation, the balanced equation? It was a 2. What was my number in front of Br2 up here in the balanced equation? It's a 1, right? We don't write ones, but it's a 1. So if my ratio says every time 1 mole of Br2 reacts, I will get 2 moles of KBr. Okay, 1 mole of Br2 here, and 2 moles of KBr here. Okay, so this 1 and this 2, this 1 and this 2 have come from the balanced chemical equation. This 2 was given in the question, and this n is my unknown. So now if I go back and solve for this, I say 2 moles of KBr. Notice that I have moles of KBr here and moles of KBr in the denominator. Let me get rid of those arrows because they're just kind of in the way. I have moles of KBr in the numerator and moles of KBr in the denominator, so those disappear, and the units that I'm left with are moles of Br2. Right? Moles of Br2. That's what I'm looking for, right? I'm looking for how many moles of Br2. So I'm going to take my 2 times 1 divided by 2. Right? 2 times 1 divided by 2. Oops. And I'm going to get 1 mole of Br2. Okay, so the number of moles of Br2 required to make 2 moles of KBr is 1 mole of Br2. Now, if I actually look at the equation, I kind of knew that already from the equation, because in the equation it shows me that 1 mole of Br2 always makes 2 moles of KBr. So if I'm trying to make 2 moles of KBr, this has to be 1 mole. Right? Logic would tell me that without even doing the question. Right? But we're going to do the question because it's not always going to be nearly that straightforward. Let's keep on going here. Let's say, what about if I need to know the number of moles of potassium? A number of moles of potassium is equal to my question mark there. So if I'm trying to solve for the number of moles of potassium here, it's going to be equal to the number of moles that I was given in the question. I was given this one here, right? 2 moles. I was given that number, 2 moles of KBr. And then I'm going to use my mole ratio. I want to know how many moles of K from my balanced equation. I can see in the balanced equation there's 2 moles of potassium. And in the balanced equation I have 2 moles of KBr. Right? I have 2 moles of potassium over here, and I have 2 moles of KBr over there. Right? And then I was given this 2 moles in the question, and that's the 2 moles that I have down here. Okay, so if I go ahead and do the math now, I end up with my number of moles of K, potassium, is equal to 2 times 2 divided by 2. So 2 times 2 is 4, divided by 2 is 2 moles. And look at my units. I have moles of KBr here and moles of KBr in the denominator. So they will cancel each other out. And I'm left with moles of K. Right, there's my units. So my number of moles of K is 2 moles of K, 2 moles of potassium. So those are my mole ratios. This is a mole ratio here. It comes directly from my balanced chemical equation. Let me erase some of my messiness here. Oops. Undo. Let's get rid of all this. So if I go back to my original balanced equation there, let me get rid of some of these guys. I have a number of mole ratios that work. Right, let's get rid of all this stuff. So my mole ratios are the ratio of one reactant or product to another reactant or product. So my 1 mole ratio that I might have here would be the mole ratio of 2 moles of potassium are used every time 1 mole of Br2 is used. Or I could say 2 moles of potassium are used every time 2 moles of KBr are made. Or I could say 1 mole of Br2 is used every time I make 2 moles of KBr. Right? Or I could do it the other way around. I could say 2 moles of KBr are produced every time I use 2 moles of potassium. So the question becomes, there's all kinds of possibilities here. 2 moles of KBr are produced every time I use 1 mole of Br2. Right? All these different possibilities that are coming from my original balanced equation here. Right? By using the balanced equation, I can come up with ratios. Ratios of potassium to bromine, potassium to KBr, bromine to KBr, KBr to bromine, KBr to K. Right? And then ultimately the question becomes, some of these are the opposite of each other. Right? Notice that this one here, was 2 moles of KBr, and in the denominator there, I've got 1 mole of Br2. Right? And then over here, I had 1 mole of Br2 over 2 moles of KBr, and here I have 2 moles of KBr over 1 mole of Br2. So the question becomes, how do I decide which of these different ones am I going to use? Right, I'm missing one, but it doesn't matter. Hopefully you get the idea. Now, if I look at the equation or the question I was just doing, I'm trying to solve for the number of moles of K over here, and I'm trying to use the number of moles of KBr. So I want to have an answer that's in moles of K. So I want to have how many moles of K from my equation? It was 2. And I want to have how many moles of KBr from my equation so that I can get rid of this KBr here. And when I get rid of the moles of KBr, I'll be left with just moles of K. So the trick to this whole thing is figuring out which combination am I going to use here, which mole ratio to get the answer. Okay, so I'm going to give you some of these to, oh, actually I'm going to do one more example. Okay, so one more example. So if I look at the example which is in our textbook, sample 1, on page 214, the equation says two H2Os react to make 2 hydrogen gases plus an oxygen gas. Notice the numbers in my balanced equation. So I've got, I've got 2 H2Os making 2 H2s and O2 gas. Now over here I've got 4 hydrogens, here I've got 4 hydrogens, here I've got 2 oxygens, here I've got 2 oxygens, so it's balanced. Now, the question says, an astronaut on the space shuttle consumes 22 moles of oxygen each day. 22 moles of oxygen. So let's get rid of this. And I'm going to put N equals 22 moles. And the question says, how much water do I need to use to make that much oxygen? So the question is, how many moles of water do I need to use to make 22 moles of oxygen? Now, if I say the number of moles of H2O, which is my unknown, that's going to be equal to my known, which is the number of moles of oxygen, times my mole ratio. So the mole ratio has got the compound that I'm trying to get rid of, which in this case is the oxygen, right? I'm trying to get rid of the oxygen here, and I'm trying to get water for my answer. So I'm going to put my water on top. I can see from the balanced equation, says there's 2 moles of water, and I can see that I've got oxygen is just 1 mole. Oops, in my balanced equation, it's just 1 mole. 1 mole of oxygen. Okay. Now, I should actually have put my number of moles of oxygen in there, which is 22. So I end up with 22 moles of oxygen. 22 moles of oxygen times 2 moles of H2O from the balanced equation divided by 1 mole of O2 from the balanced equation, so that my moles of O2 and my moles of O2, top and bottom, disappear, and I'm left with my units, which are moles of H2O, which is what I'm looking for, right? How many moles of H2O? So I'm going to do my math now. Number of moles of H2O is equal to 22 times 2, that's 44, divided by 1, 44 moles. And notice that my units here are moles of H2O. So my number of moles of H2O is equal to 44 moles of H2O. Okay, and that's my answer. Okay, so there's question sample problem 1 on page 214. So in your textbook, I'm going to leave you with, so I've just done the sample problem here. I'm going to leave you with these 3 questions to try. Really